Okay, let's start. First off, thanks everyone for coming to this talk. I really appreciate it. It's getting late in the afternoon and I know there's a lot of other great stuff going on. So this talk is titled Beyond JavaScript Frameworks, Writing Reliable Web Apps with Elm. How many of you are familiar with Elm to some degree from before? Okay, so a few hands, not too many. That's good. That means that you are all of you in the target audience for this talk. So on the next slide, I have a question that I always start this talk with. And this is the first time I'm doing this talk in the Bay Area. So I'm a bit excited to see if there's a high rate of hands up on this one. So who are familiar with Jonathan Ive? Who is Jonathan Ive? Okay, maybe 3/4 of you. So Jonathan Ive is, of course, the Chief Design Officer at Apple. And I think that he's the second most influential person behind all of Apple's products, behind Steve Jobs, of course. And the reason I like to start with talking about Jonathan Ive is that one of my colleagues has this great quote about Elm that I really like. And the quote is a bit weird and crazy in a way, but it also captures how I experience Elm. So he said that Elm is like Jonathan Ive would have designed a programming language. It is minimalistic, it is user-friendly, and it just works. So I guess you see my point why it's a bit, I can't find the English word, but you understand. But in a way still, it really captures how Elm works, at least to me. So during the next 38 minutes, I'm going to try to show you why this quote makes sense. So I guess a lot of you write JavaScript at work, right? Most of you. So I have some questions for you. You don't have to raise your hands on these ones. You can just think for yourself. So maybe you ever shipped an app to production with confidence that it would never fail or crash, right? For me, no, never. Maybe did you ever feel completely safe after a large refactor of your front-end code? Like really large, touching all of the core data modeling stuff? For me, it's a no. Did you ever become overwhelmed with the amount of front-end technology that you need to know in 2018, right? There's all these things, there's new things every day. How do you know which ones to trust and which ones to actually invest your time in? And because of this, did you ever feel like not everyone on your team was comfortable doing the front-end tasks? I know for all of the teams that I have been a part of, there's the front-end people, there's the back-end people, and there's a few persons that are actually comfortable with both. So for me, having worked as a full-time JavaScript developer and tech lead for the past 6 years, I would have to say check to the JavaScript fatigue. There's even a word for that. And check for there were some large refactors. You know, you have to change the code because you just can't keep going with your existing code base, but you still have to do it. And then the dedicated front-end developers, I myself is one, and also the nail-biting deploys. I used to work for a large bank, and we did this huge rewrite of one of the front-end apps, and it had to be launched before the Winter Olympics because they had sponsored the ski team, right? So it had to be done. And just pushing that button, it should work, but what if, right? So I will argue that Elm addresses these issues. It's not like a silver bullet. It doesn't completely fix them, but it addresses them and makes my life at least a little bit easier in terms of those pains. And I would argue that it also provides a dedicated pair programmer through the compiler, because the compiler is much stronger than Babel or whatever your transpiling tool in JavaScript is. And that pair programmer will never be hungover, never sick, never on vacation. It's always there holding your hand, helping you. And it also has really great error messages. You know, John Carmack, the main developer behind Doom, Commander Keen, Quake, all of those games, has this great quote about Elm, that Elm is actually the one programming language that has really helpful error messages. And lastly, the big, like the virtual DOM to React, the quote for Elm is no runtime errors. Your code won't crash. Of course, you can have logical bugs, but your code won't crash in production. It's almost 100% true. It's like 99% true. So who am I to be talking about Elm? I didn't write Elm. I don't live in SF. I'm not a part of the core Elm evangelist people. but I use Elm at work. So here's the slide about me. My name is Erik Wendel. That's a German last name, but I'm Norwegian. I live in Oslo, Norway. I would say I'm a user interface expert. We're kind of not used to being really explicit about experience in Norway, so it's a bit uncomfortable for me to label myself an expert, but I guess I am. I've worked mostly with JavaScript and large single-page apps in my career, working with some large Norwegian companies like one of the biggest banks and currently the railway company. I work as a web development lead at the consultancy in Norway called Beck, where we serve Elm in production to over 1 million users. And mind you, in Norway, 1 million users is 1/5 of the population. So that's quite a large, commonly used app in Norway. So almost 2 years ago, I founded the Oslo Elm Meetup, which is one of the most active Elm Meetup groups in the world, actually. And 1 year after that, I founded Oslo Elm Day, which is the world's 3rd Elm conference, where we gathered 10 speakers from 6 countries. I'll tell you more about it afterwards. But the point of this slide is to show you that I'm really excited about Elm. I'm using it at work, and that's why I'm here today. So today's agenda looks like this. I'm going to show you how Elm works, and I'm going to compare it to the JavaScript of today. And to me, the JavaScript of today is React with Redux if the app is large enough, and maybe TypeScript and some other libraries put on top. That's a really great stack. And secondly, I'm going to show you a small app example just to show you how the IDE works and how the editor tooling is and just how to set up a really small app. So that'll be the counter app that Redux used. And lastly, I'm going to talk a little bit about whether anyone uses Elm or not. I mean, it's cool if it's a nice toy and all, but is it actually something that you can use at work or not? So I'll attempt to answer that question. So let's dive into how Elm works. So Elm is a language compiling to JavaScript. It's not another library and it's not another framework. So you can't directly compare Elm to React or Elm to Angular or Elm to Redux. Because just like Apple really tries to control the entire user experience they make the hardware, they make the software, they control the app store, they really want to be in control of everything the user interfaces with, right? And you can say that I don't like that. I like to be able to install my own apps without going through the App Store. There's a lot of things that you can dislike about that. But in a way, it's how you can really control the entire experience, right? And just like Apple does that, Elm intends to do the same thing. It's a full language. It's not just a framework. So it can go farther in the promises it gives you on how it is to work with. And Elm and JavaScript are pretty much totally different. They're different in terms of syntax and in terms of semantics. So you'd have to learn a new way to program in a way. And just like React, Elm uses pure functions. Well, you mostly use pure functions with React, but you also use the virtual DOM. So you only need to say that this is what I want my DOM to look like, and Elm will take care of the rest, just like with React. And you use Elm to create a tree of components. So in that way, it's really familiar for everyone who has used React in the past. But unlike React, Elm does not allow component state, which means that all of your state needs to live in one single big blob of data, just like you do with Redux, right? So you can say that Elm uses the Redux architecture. But the cool thing is that it's actually the other way around. The guy who created Redux, a Russian guy called Dan Abramov, tried out Elm sometime in 2014. And he really liked that way of organizing your application architecture. And then some months after that, Redux came to be, and he is very honest about that. In the Redux docs, there's a clear homage to the way Elm works. So I was a really big proponent of React and Redux. So my friends come and ask me, so what's up with that? Do you not recommend that anymore? Do you only like Elm now? And I would say that Elm is basically React and Redux, but with type safety and some other good stuff. So it's just more of the same in a way. It's just one step further on the same path, at least in my view. So let's look at how it works. Your Elm program would compile down to a JavaScript file. So you would just include that JavaScript file in your HTML with a script tag. And then you would say to Elm, hey Elm, please render my main app into this node. So remember, Facebook started with a large PHP app. And then they came to a point where they couldn't create new stuff fast enough. So that's when they started experimenting with React. And they couldn't just rewrite entire Facebook.com in React over like a few months or a year or something. So they needed to start with like the most difficult parts, which was the chat application. So just like React could just be inserted into a large app for just a small part of it, that can also be done with Elm. So it's really easy to just try out Elm for a part of your application. So correctness, maintainability of the code, and the developer friendliness is one of the biggest focus points in Elm. And you can really feel that when you're working with Elm. And all of those comes from the ML family of languages, like F#, OCaml. Facebook is playing a lot around with OCaml these days, and also Haskell. So Elm is like a simpler, more dumbed down version of Haskell. It has a lot of the same language constructions, but it's just simpler. And that's why also Elm can at least attempt to promise you no runtime errors. And of course, when I say errors, I mean crashes. You can return +1 when you intended to return -1 from your function. Elm won't help you, won't stop you from doing that. But Elm will try to stop you from crashing in production. And Elm is really, really opinionated. Elm has one way to solve all of the common problems. It's not like in JavaScript where you have like 100 date picker libraries, right? Elm would like to have one. That's the Elm way. So for some people, they don't like that. They want to have 100 things that you can pick and choose from, right? But for me, having just one great solution to every problem makes sense. So let's look at some key language features in Elm. So all of the data is immutable. You can't just opt in for immutability. It's there by default, and you can't turn it off. And there's no null. And no null means no null pointer exception. So that's a big part of how they can promise you no runtime errors. So there's no statements in the language. It's expression only. Everything evaluates to a value. If you would want to do a side effect, you would have to pass that to the Elm runtime and ask Elm to do that for you. Let's say a network call, accessing local storage, generating a random number, stuff like that. So it's a totally pure language. And number 4 is really interesting because in JavaScript, you could have Redux, you could have Flux, you could have Angular, you could have Vue, you could have a lot of different solutions for your state management and your application architecture. But in Elm, that's just a feature of the language. If you do Elm, you do the Elm architecture. It is not something you can opt into. It's just there. It's a part of the language, as I will show you later on. So for me, as a consultant, if I enter a new project, a new team that does Elm, I know how the app works on a high level. So that's a big benefit. And lastly, the creator of Elm really wants Elm to remain small. I mean, if you look at the JavaScript standard, there's new stuff coming every year, and you could debate whether all of that new stuff is really needed or only serves to like bloat the language. There's a huge debate. But in Elm, they chose to just keep the core really small. And that makes it pretty easy to learn. But all of these features really click together really well, just like Legos. So you can create really large and expressive applications using few constructs. So let's look at some code. As Elm is a functional language, functions are really at the core of the language. So here we see a function called increment that accepts one parameter x and returns x plus 1. Pretty simple stuff. But then we call that function with for and put the result in a constant called 5. In JavaScript, 5 would be a variable, but since every data is immutable, it's a constant, right? So in JavaScript, you would call increment using parents or parentheses on both sides of the for. But in Elm and Elm-like languages, you use space to invoke a function. So that's a bit weird. And also, as Elm is a typed language and is a strongly and statically typed language, it's kind of weird that there's no types here. And that's because Elm can infer all of your types. So Elm will read, okay, there's something called increment, and okay, it's a function because there's something between the function name and the equal sign. And they call that x, okay. And then we see that, okay, x, you use the plus operator together with the x, so x must be a number, right? Because you don't use the plus to do string concatenation, that's a different operator. So Elm can successfully infer all the types in your app. But you'd always want to specify the types. And there's several reasons to do that. One of them is that it's a great documentation for the developer coming after you. You can, for these kinds of functions, it's really trivial, right? But for bigger functions, it's really helpful to see what does this function accept and what does it return. And also, it's a way of telling your dedicated pair programmer, the compiler, that I intend this function to work like this. And if you screw that up, your compiler will immediately be able to tell you that, okay, you told me you wanted to do this, but I can see that you are doing this, so there's an error here. So you read this thing as increment has type from int to int. So the arrow means that it's a function with one argument. So if you have two arguments, you'll have two arrows, basically. So we have looked at the constants for storing data. We have tuples that uses the parentheses. And also you have something that's comparable to the JavaScript object. In Elm, they call that a record. So you can say that person has type, object or record, with a field called name of value string, or of type string, and a field called age of type int. And then we actually create the thing. And you see here that the formatting is a bit weird compared to JavaScript. You have the comma on a new line, and then you immediately start the first property of the record on the same line as the opening curly brace. And that's just the way they do it in Elm. And that's one of those things that you just have to take it or leave it, right? To me, this is a really big deal in the beginning. I really didn't like this formatting. But there's this tool that will automatically format your code just like prettier in JavaScript. So it will be like this. So you have to just give it a couple of weeks and see if you can learn to like it or not. And for me, I really learned to like it after 2 weeks. So let's move on. It really gets exciting when you start creating new types. Just like in Java or C#, when you start creating new classes, that's when you really start to create proper applications. So there's two ways to create new types. The first one is to create what we call a type alias. And that means that you can say that whenever something has this shape, you might as well call it this. So let's say you have a tuple of ints. We can create a type alias to say that that's basically just coordinates, right? Or something else that makes sense in your application. And then you can use that type everywhere in your application. You can also kind of like remapping the primitive types like int. So you can use a discount. It's basically just an int, but let's call it a discount because that makes more sense when you read the code. But this is, makes most sense when you use it in conjunction with the records. So you can kind of like you make a class in Java or C#, you can say that whenever a structured piece of data, or a hash map or a record as we call it, looks like this, you might as well call it a customer. But customer isn't like a constructor or a class, or you can't like inherit from that. It's just whenever some data looks like this, you might as well call it this. So it's an alias. But the next way to create types is a lot more interesting. So here's an example. Let's say all customers have a type. So in JavaScript, you would use just like a string because you don't have an enum in JavaScript. So let's say I am a student customer. So we write that as a string, the string student. And all students have a student discount represented as an int. 0 means no discount. 100 means you can get stuff for free. So I have 50% student discount. And then we fast forward some years. And now I'm the corporate type of customer. So I shouldn't have a discount anymore. But I have a company name that should appear on the invoice because it's some legal stuff. And there's some problems here. I still need the student discount field. In JavaScript, you could just omit the field or set it to null or undefined. But remember, we've said that customers, they have that field. So you can't just omit the field in Elm. And you can't set it to null because there's no null. You can't put it set in undefined because there's no undefined. So we need to give it a value for the app to type check. So you can set it to 0 because I don't have a discount, right? But why do I have that field? It doesn't make sense. And also, it would be really easy to mistype this string here. And my application would crash because it doesn't understand. I probably have some sort of if sentence, right, to match, is it a student or a corporate? And then none of my patterns would match, and my app would just crash. And also, if I'm a student, I would need to have an empty string here because I just need to have a value there, right? I guess you're seeing my point. So there's this great construct called union types, or discriminated unions in F#, that allows you to say that this type, called customer type, is one of the following values. It has to be one of them. It can't be null, it can't be undefined, it has to be one of these three. So you're either a student, a corporate, or a private customer. And you have to have one of those values. So your compiler will ensure that that field will have one of those values. But now we lost the student discount and we lost the corporate name. So we could just add that by associating data with the different branches there. So this basically means that whenever you have a student value, you're guaranteed that it will have an int that corresponds to it. You're kind of like wrapping data inside of the value. And similarly for the corporate value, you know that whenever you have a corporate value, you will have a string. The compiler won't compile unless every time you create a corporate value, you have to give it a string. It's like these two are constructors that take one argument. And on the other side of things, you would unwrap it using something called pattern matching. I think when I discovered pattern matching, that's probably the most excited I've been since I was like in computer science at school, learning new stuff. So you use the case keyword. You say, what do I want to match? So I want to match on a customer type. So then Elm knows that it's either this value, right? Or this one, or this one. So the IDE can just automatically insert all of these for me. And we know that whenever you have a student, you will have a discount, which is of type discount, which is an int. And whenever you have a corporate value, you will have a name, which is a company name, which is a string. And then you basically have type safe and wrapping of all of these values. So they're all of the type of customer type, but the different branches have different data. So they're all the same type, but different. So I currently work for a Norwegian train company. I think we have maybe 20 different types of tickets. You have like a return ticket, one-way ticket, you have a senior citizen ticket, you have tickets that only valid in this zone, and lots of different stuff. And they all have different fields, right? And we need to represent that as a type ticket. And using the union type, you can just have one branch for each of the possible ticket types, and then associate it with a record that has a certain shape. So you'll be guaranteed that whenever you have a return ticket, you'll always have a return station and then a return leg, right? So your type system will ensure that you always have the data that you're supposed to have. That's a really powerful feature. Another great usage of union types is the maybe. It's also known as an optional, or it has a lot of different names. But in Elm, it's called a maybe, and that's whenever you have some data that might be, let's say, null in JavaScript. Either you have a value for this data, or you don't. So either you have, let's say, you have an int that's sometimes there, and sometimes it's not there. So you could have a maybe int, where a is an int. So that's either just the int, you have something there. You don't have nothing, you have an int, or nothing. So this thing comes built in with Elm. So whenever you might have a value, you could use this. And let's see an example of how you'd use this. Let's say you are creating a game. And before you finish the game for the first time, you don't have a high score because you need to complete the game to have a high score value. And once you complete the game, you'll have a value there. So you could be a maybe int. Either you have just int or nothing. Then you could create a method to extract that value. So you would pattern match on game.highscore, and that's either just and the int or nothing. And you'd return different things depending on which of the two different values of the type maybe you would have. So this is how Elm stops you from doing stupid stuff and crashing your app. Let's say you do a network call, an AJAX call. It might fail, right? There's a lot of different ways it might fail. So you would wrap that in a data structure like this. And you'd say, what if it times out? What if there's some unknown network error? And Elm would enforce that you handle that. Let's say you try to get the first element of a list, but what if that list is empty, right? So you'd get maybe something back. And then Elm would force you to, what if the list was empty? So in JavaScript, you could just code on by and forget about that corner case and just wait it to crash. afraid to crash, right? But with Elm, you would be forced to handle that up front. So it's a bit more cumbersome. You have to write a bit more code, but you know that the language has your back. Okay, so let's continue to HTML. As we write web apps, HTML is pretty central. So this is a small snippet of HTML. We have 2 nodes, actually 3, because this one will be a text node. We have a class attribute. So how would you would create this in Elm just like you do everything else by calling functions. So for every HTML tag, there's a corresponding function in Elm that will create that tag for you. So this is a bit like React works if you don't use JSX. It's just functions. There's a function for div, there's a function for span, there's a function for input, etc., etc. So all of the functions in Elm for creating HTML, they have the same function signature. It accepts first one list, that's a list of attributes like class, ID, onClick, all of those. And the second list is all of the children. So here we create a div with the class attribute, and it contains a span, which contains the text banzai. And all of this has a special type called HTML. And since we're not emitting any events, there's no onClick, there's no onScroll, there's no input elements, we don't have any outputted events, so we just put A for anything. But in this example, where we add an onClick to this span, we'd have to say to Elm, what type is the event that's put back into the system when you click on this thing? So there's a convention that you just call that for MSG. I'll show you a bit more when we reach the app example. So we've reached the Elm architecture, and if anyone has used Redux before, this will sound pretty familiar. I said that we have all of your application state in one big blob of data in Elm. So that's like the store in Redux. And you write your own type using the type alias, and you say that whenever a big blob of data has this shape, that's our model. So we create our own type for that. So this is the first part of the Elm architecture. We need to render that data using HTML. We have to have something on screen, right, for the user to see. So that's our view function. So it accepts a model, and you return some HTML. It's pretty straightforward. You just create a lot of different functions, calling the HTML functions like div, etc., as I just showed you, and you create your entire outputted HTML. And lastly, you need to change your data whenever something happens in your app. Maybe your user times out, your user clicks on something, you receive a response from the server, whatever. And that's the update function. So that's basically all of the reducers in your React Redux app. So you would accept a message, which is all of the things that can happen in your app. And then you accept the old model, like how was the world before this thing happened, and then you return the new model. So it's basically the reducer of Redux. So let's think about all of these features that Elm has that I've just shown you. What would you need in the JavaScript world to recreate that? You would need React, or something that has the virtual DOM, right, to create a tree of components. You would need Redux to have the architecture of the unidirectional data flow, all of your data in one big tree. You would need immutable.js or some other immutability library to have immutable data. You would need TypeScript or Flow to get type safety, but considerably weaker type safety than you would have with Elm. And lastly, maybe ESLint or some other like code formatting, code style tools to avoid you landing in one of the many pitfalls of Elm, with JavaScript. So I'm sure there's other libraries you can pack on here, but I think this is a pretty good package for JavaScript. And Elm gives you all of this out of the box. And this is why my title is called Beyond JavaScript Frameworks. So let me show you how to create the counter app, just how everything fits together and how it works. I'll just have to fix my screen like that. Normally, I live code this thing, but I don't have time for that today because I only have 40 minutes and not 60. Hope that's all right. Are you able to see the code in the back?
Now, is this Adam right here?
That's Adam, yeah. So let me start with the main function. I could try to remove this thing and just output hello world. I'm in the wrong file. Faucet means solution in Norwegian, so that file isn't being run. Now the Elm compiler will yell at me because I'm doing something illegal. So Elm is telling me pretty clearly that the main function needs HTML, SVG, or a program, because those are the types that it knows how to render on the screen. But I gave it a string, so Elm gets confused. So it's really explicit and clear about what I did wrong. So I would need to call a function called text that accepts a string and returns an HTML text node, which is of type HTML that Elm knows how to render, like that. And I'd like to show you like all of the error messages and standard all day, but I only have time to show you a few of them. But they're all pretty clear and concise, and usually Elm tells you to, maybe you want this function, maybe you need to read this section of the documentation, maybe you intended to do this. And if you have a typo, it will look for objects that have the similar names, and if you're missing a field, it will pretty clearly tell you that, etc., etc. So let's undo back here. So this is the program type. We're calling the beginner program function, and remember the space here means that we call that function with one parameter being the object with these three fields. So that's basically the Elm architecture, the three pieces. So we have our model, and it's this small example, that's just a number. We don't need a lot of stuff. But in any real world app, there would be a huge blob of data, some user data, some data from the server, some login token, etc. And then we actually create our model. So we're saying that model with a lowercase m is of type model. So uppercase always means this is type reference. And I guess most people would do this and then save the file, and then Elm format would yell at you and say, do it like this, it's nicer. We all do it like this, and the world would be a nice place to work. To me, in the beginning, that was a bit, I wanted to turn it off, but then all my Elm colleagues yelled at me, so I got used to it, and now I really like it. And here's our view function. We take in a model, and then we basically just create our HTML structure. And then we have our on-click functions saying what we need to do when you click on the buttons. And that's the message type. So remember, that's the union type. So the message type has one of a finite set of values. So in this really small app, you can just do increment and decrement. That's the interaction that the app knows how to handle. In a real world app, you might have user did timeout, user did buy on product button X, user bought this, whatever. So if your boss came up to you and asked, do we support this or that? You could just check the message list and see, is there a value for that? Because if there's not, you won't be able to change the data in your update function because of that. And then you know it's not supported. And the update function is where you'd handle that. So let me remove this pattern matching and show you how Adam is actually quite smart. Adam knows that, okay, you're pattern matching on something that's of type message. And I know that type message has these two branches. So I'll just insert them for you, right? And if you have 100 branches, that's really neat. And also, if you add a branch, let's say we start selling a new type of ticket where I work, then Elm will just point at my code and say, I need to add your new type here, and here, and here, and here, because you're saying that you're handling this type here, but I know that now that there's a new branch of this type, so it doesn't compile, it doesn't make sense. So instead of me just opening the browser, refreshing, and having to click to that page and to find the app actually crashing, Elm would just tell me up front that I know this won't work, so I just won't let you compile your code. Just fix this first. And that's really, really nice, especially if you have a large app, right? And lastly, we have the main function that just puts everything together. And something that's worth noting here is that in a JavaScript application, every line of every file could potentially have something there that will modify the DOM. Every line could potentially have a document dot something something, while as in Elm, the only thing that's actually outputted to the screen is the main function. So if you need to find out what's going on in the app, you just find the main function and there it is. And also, really small, subtle, nice touch when you're working in a lot of different apps or apps you don't know. So let's go back to the presentation. So the last part is, does anyone actually use Elm? I have a few stories to share about that. So Elm has been around for quite a few years. There's a lot of conference talks about Elm, blog posts, etc. Is it really ready for production? And if so, what are people using it for? Are they actually using it for mission-critical, business-critical stuff? If so, what's their stories? So I imagine that if I'm going to be able to answer that question, I need to meet a lot of people who are interested in Elm and are using Elm. So the easiest thing to do was just to create a new meetup group. And I did zero PR. I just created a group, created an event, and just let it there. And after about a month or two, we had 150 members, so they just found it by themselves. And to me, that were telling me that there's a lot of interest for Elm, at least. So we had about 42 attendees on the first meetup. Now we're doing monthly meetups with about 30 to 40 people. And in Oslo, that's actually quite big. It's one of the most active meetup groups. And now, as of January this year, we have about 400 people, and which makes it, I think, the fourth biggest meetup in Oslo. So that's quite nice. So I've gotten the chance to meet a lot of people and talk a lot about Elm here. Last year, I found out that one of the biggest names in Elm, called Richard Feldman, who lives here in SF, he does a lot of talks on Elm. He was flying to Paris to do a talk at a conference. So I messaged him and asked, hey, would you like to come by Oslo on your way home? And even before he responded to me, he had already rebooked his flight and he was going to do it. So we had to ask ourselves, what do we want to do with that? Do we want to do like a meetup with like a much bigger name than usual? Or do we want to create a conference? So we went for the conference approach and did a one-day single-track conference in Oslo. We attracted about 100 paying attendees and 10 speakers from 5 different countries. And to me, in a small country like Norway, this told me that there's actually a lot of interest here. And all the talks are on YouTube if you want to check them out. And we're going to do it again this fall.
And the talks are in English?
All of the talks are in English.
Great.
So I did all of this to try to answer this question. Could I actually recommend using Elm to one of my clients? And the short story version is just, yes, people are actually using Elm. So I'd like to show you 2 example apps that were written in Elm for different reasons and have achieved different positive effects from using Elm. So the first one is one of my friends helped organize this large conference in Oslo called the Java Zone. It's not just about Java, it's about everything, but the name is such a big brand in Scandinavia, so they don't dare to just change the name. But it has about 3,000 attendees, really large expo area. It's non-profit, community-driven, really cool. And my friend is the only like front-end guy there. He's really good at JavaScript, and all of the other organizers are Java experts. So he was tasked with creating a new version of this large info screen app, where you can asynchronously like just push new slides to the software. And it will poll every second to get new slides containing tweets, videos, pictures, text, a combination, whatever. And he was thinking that, okay, so there's about 3,000 people here, a lot of them being my clients, my friends from school, my friends from work, and other friends. And here we have like 7 times 10 meters times 2 screens that would show my app crashing if I do something wrong in front of all my friends, clients, etc. So he heard about this new Elm thing and he decided to check it out. He was pretty happy. He was able to create this thing during just a couple of weeks in his spare time. And it didn't crash. So the other people in the committee wanted to try some Elm. And mind you, they have done very little front-end stuff before. So I think one of the most positive effects for them is that suddenly the entire team was doing front-end stuff. Because the Java people suddenly felt at home. They had a compiler that would yell at them when they did something wrong. They had the types. So it felt a bit more like home than JavaScript did. And they didn't have to think about all the frameworks and Webpack and gluing things together. They can just create Elm app, new app, enter, and then they're ready to create something. So to me, that's a really, really big win. And now I know they're using Elm for their other systems, like their call for papers and reviewing the papers and sending emails to the attendees, etc., etc. And the other project is where I currently work. I wanted to use Elm for a rewrite of the website where we sell train tickets. And I need to convince my team, the client, etc. So every year we take in a couple of summer interns. It's a recruitment thing. And I said that, what if we task 2 interns that just finished the third year of computer science college to recreate the seat booking app in Elm, and they didn't know Elm from beforehand. And if they're able to do that in 6 weeks and produce code that we're happy about, and we can put it in production, and they liked working with Elm, then maybe we should try out Elm for the rest of the team. And of course, you couldn't say no to that, so they also were pretty cheap, so the client just win-win-win. And the cool thing was that they loved working with Elm. They thought it was a shame that they had to use like 2 weeks to do the Elm thing, and then 4 weeks to work with our legacy Android and iOS code to integrate the web app, right? So their feedback was, more of Elm, please, during those 6 or 7 weeks. And we were happy with the code. The app worked, so it's now in production. And we basically started using Elm for the rest of the app, where we now have over 1 million page view unique users every month buying tickets. So to summarize, many people are experimenting. 100% actually are saying would use again. And to me, that's one of the strongest findings of my walking around talking to people, very unscientific survey of the Norwegian and Scandinavian Elm community. People find it really easy to onboard new people, especially if you have FP experience or React or Redux experience. But there's a bit of a learning curve learning the language itself. But that's easily transferable to F# or Camel Haskell, so it's not. It's knowledge that's really useful to have. And the world's biggest adopter is, of course, here in SF, a company called Norred Inc. And I think they're closing in on 300,000 lines of code. And last week, they had their first runtime error, actually. One of their developers wrote debug.crash and shipped that to production. And that does exactly what the method is saying. It crashes the app. So that's a bit cool. So I guess I'm really sounding like an evangelist, like saying this is a silver bullet, right? But there's obviously bad use cases for Elm as well. If you're making a prototype or something that's really small and you just want it out the door really fast, if you're a startup and you just want to test the product market fit and just get something done and ship it, then I would use JavaScript because I work faster there and the code quality isn't that important. If you use a lot of third-party code, JavaScript is much easier to interface with than Elm, because Elm puts up these walls, right, to protect you from the possibly failing third-party libraries. So if your app basically just glues together lots of different NPM packages, Elm wouldn't provide that much of a benefit, right? And if your team doesn't know functional programming and doesn't want to learn, the learning curve could be too big. But there are some great use cases on the other hand. If you know that the refactors are coming, that you're creating a code base that will live for a long time, and that you will refactor, you won't throw it out, you will actually make that code base nice over time. Elm works great. Also, the complex domain logic things are very well modeled using union types and the strong type system of Elm. That's why Haskell is being used for a lot of compiler stuff, where you really need to ensure that the code is correct. And when you have a team where you have little or no knowledge of JavaScript, I don't think it might be easier to learn Elm. I almost say that I know it will be easier to learn Elm. Instead of learning JavaScript, React, Redux, TypeScript, immutable.js, Webpack, etc., etc., etc. So this is the case for my team. We have, I think, 3 really JavaScript experts and maybe 5 people who only know Java. But they really enjoy working with Elm. So for us, this has enabled us to use to enable the entire team to do front-end tasks. So I feel that all of these challenges are to some degree addressed by Elm. And in an attempt to summarize, you get a language without runtime errors, you get superb refactoring support, you get front-end technology for the entire team. Also, you have a delightful developer experience. Redux is built in, React is built in, but on the other hand, you have currently a pretty small ecosystem compared to JavaScript. I mean, it's impossible to not have a minuscule ecosystem compared to JavaScript, right? There's just so much stuff out there. And a lot of people are scared that you don't have the big backer, like React has Facebook, Angular has Google, etc. So I think in the Elm community, you have more companies backing it than just one. but it could be an issue, of course. And you have to write a bit more code. So if your development experience is based on how much code you actually have to write to get something done, then of course JavaScript is more compressed and doesn't enforce you to handle all the weird corner cases. But on the other hand, your code might and will blow up. So is this a good deal? I guess it's no secret that I think so. But my purpose here is to give you enough insight to decide for yourself. So what's interesting here is what you think. So I hope that I've been able to make you curious. We're doing a workshop on Thursday, actually, here at the conference. So if you're free on Thursday and you want to learn some Elm, please sign up. You do that by sending an email to info@forward.js. It's me and my colleague Ingar, who is somewhere back there. So we'll take good care of you and teach you enough Elm to go home and actually use it at work, or try it at work, or write a side project, or whatever, during those 8 hours. Or you could just join the Elm Slack, which is really, really friendly. They have this policy of trying to answer every single question on there by new users. It's a really, really friendly community. Lastly, check out your local Elm meetup. I know there's a really active community here in the Bay Area and lots of other cities as well. And I guess that's about it. There's a link to the slides and workshop available at is.gd/elm. Thank you for coming.